In today's lecture, we are going to discuss the third objective we are going to meet. That is, we'll be discussing the physical properties of metals. And among the physical properties, we'll be discussing the high melting and the boiling point of the metals, the electrical conductivity of the metals, and the malleability and ductility. And we'll be discussing and I'll be explaining you that why metals have high melting and the boiling points, why metals are good conductor of electricity, and why metals are malleable and ductile. So these are the three objectives I'm going to meet today in today's lecture. So in the previous lecture, I've already explained that metals are the structures in which the metal atoms are tightly held and they are strong metallic bond present between the metal atoms. So based on that information and our prior knowledge, we know that the metallic bond is a very strong bond. So when the strong bond is present between the metal atoms, so that is very difficult to break that bond. If you want to separate the metal atoms, it will require lots of energy in the form of heat. So what that will do, that will increase the melting and the boiling point of the metals. So if we tend to answer the question that why metals have high melting and the boiling point, then what we are going to write is, according to the marking scheme, we'll write metal atoms are held together by a strong metallic bond, which is an electrostatic force of attraction between the positively charged metal ions and negatively charged mobile electrons. This is a strong bond. Lots of heat is required to break this bond, so metals are tend to have high melting at the boiling point. We can also answer it this way: the metal tend to have the high melting at the boiling point because of the strength of the metallic bond. The strength of the bond varies from metal to metal. So in many places in the past papers, they are going to ask you that compare the melting point, the boiling point of the certain metals. They'll give you the names like aluminium, sodium, magnesium. So how would you know that among these metals, in which metal the bond is stronger? So how do you know that? We know that every metal doesn't tend to lose the same number of electron from the valence shell. So of course they'll not be having the same number of delocalized electron. So as the number of electron lost by each atom varies, so it means they are having different number of delocalized electrons. So the cloud of the negatively charged electron forming around the positively charged metal ion would be different. For example, see this structure. If you see the slide, in this slide you will see a structure in which sodium, magnesium and aluminium metal atoms are being shown, and you will see that they are losing different number of electrons from their valence electron. For example, if I'll discuss aluminium, the first one is aluminium. So if you see aluminium, the charge on the aluminium is +3. That means every aluminium atom is losing 3 electrons from its valence shell. So there are many aluminium atoms in a metallic structure. So if every aluminium atom is losing 3 electrons, so per atom, per aluminium metallic atom, every atom is losing 3 electrons. So the cloud of that delocalized or the mobile electron is going to be quite heavy. So this is where my cursor is rolling. You can see what the ratio of the mobile electron is. If moving to the magnesium structure, in magnesium structure, what happens? Every magnesium atom is losing 2 electrons per atom. So the cloud of the negatively charged mobile electron is going to be not as thicker as aluminium. So in magnesium, the ratio of the free electron or delocalized electron or mobile electron is lesser as compared to aluminium. Moving to sodium, in sodium, every sodium atom is losing 1 electron. So the purpose to compare these three structures is to show the difference in the strength of the metallic bond. So if sodium is losing 1 electron per atom, magnesium is losing 2 electrons per atom, and aluminium is losing 3 electrons per atom, it means the the thickness of the cloud is different in all the three structures. So the strength of the bond will be different, of course. In sodium, it is not as stronger as in magnesium. It is not as stronger in magnesium as in aluminium. So what happens in aluminium? You will observe the strongest metallic bond. There is another question we can cover from this explanation. They are going to ask you draw the metallic structure of aluminium, or draw the metallic structure of magnesium, or draw the metallic structure of sodium. So how you are going to draw it? You will write, if you see the cursor where I am holding, this positively charged metal ion, you will write aluminium plus 3, Al plus 3 like this, or you will write like this plus 3, however it is written on the diagram, and then you will accordingly draw the number of the mobile electrons in the structure and in the magnesium as well. So this is how we are going to cover two questions in this explanation, that comparing the strength of the metallic bond, three questions. First one we can answer through this explanation is why metals have high melting and the boiling point. Then we can answer comparing the strength of the metallic bond in these three different structures. And the third question we can answer is drawing the metallic bonding or the metal structure of sodium, magnesium and aluminum. The next part is why metals are good conductor of heat and electricity. In a previous lecture, I've already explained that the metals are having the metallic bond. In the metallic bond, you will see the sea of mobile and delocalized electron and the positively charged metal ions. I would like to just connect that lecture with this, and I will give a little bit explanation of the metallic bond, how it is formed. In the metallic structure, the metal atoms are tightly held. They are tightly packed. These metal structures have negligible spaces between them. But the valence electron of the metal atoms are loosely held or loosely attracted by the nucleus of that metal atom. So when a small amount of heat is given to that electron becomes excited and have enough energy to get free of the attraction of the nucleus. So what it will do? It will become free and start roaming and moving freely in the spaces between the metal atom. We know that when an atom is losing electron, it becomes ion. So that metal atom is no longer behaving as an atom. It will become a positively charged metal ion. So these free and mobile electrons, which are negatively charged, will become attracted to these positively charged metal ions through electrostatic force of attraction. So this electrostatic force of attraction is actually the metallic bonding. So why metals are good conductor of heat and electricity? You already know what metallic bond is. So in the metallic bond, these delocalized electrons, like these mobile and the free moving electrons, are now able to move from one part of the metallic structure to the other part. So when the potential difference will be applied, these free electrons are able to move from the high potential to the low potential. In physics, we already know that the movement of the electron is electricity. So what happens in the metallic structure? In the metallic structure, when these mobile electrons are given the potential difference, they will start moving from high potential to the low potential. So this movement of free or delocalized or mobile electron makes the metal the good conductor of electricity. So from my explanation, you must have noted that I'm talking about just the mobile electron. So what happens to the positively charged metal atoms? They will stay on their position. They are not going to move from one place to the other, or they are not moving anywhere. So whenever the question comes that why metals are good conductor of electricity, so the answer is in the metallic structure, the mobile electrons or the delocalized electrons move from high potential to low potential to make the metals good conductor of electricity. Same is the reason for their conduction of electricity for heat. So when these electrons will move, they will collide with one another. So what will happen? They will collide with the positively charged metal atoms as well. So they will transfer their heat. When the electrons are moving, they will collide with each other with the positively charged metal ions. So they'll transfer heat. So when they are transferring heat, so metal structure will become hotter and it will become like from one end to the other end, it will transfer its heat. So metal atoms are, or the metallic structures are, good conductor of heat and electricity. So what type of the question we expect from the CIE exams? So the question would be the same: why metals are good conductor, or they'll ask you explain in terms of structure and bonding why metals are good conductor of heat and electricity. So the answer we are going to write is, in the metals, the metal, or in the metallic structure, the metal atoms are held tightly by the metallic bonding, in which there are delocalized or the mobile electron present, which makes the metal good conductor of heat and electricity. So we have used the word structure, and we have used the word bonding as well. In structure, they are tightly held. In the bonding, they are having mobile electron. So we have given the reference from the structure and the bonding both. So that is going to cover our next part is why metals are malleable and ductile. To understand this, I will use the same diagram which I used yesterday, so that there shouldn't be any confusion. You can see in the diagram that here the metal atoms are arranged in the form of regular layers or the patterns. So metal change shape when force is applied on the layers. So these layers will tend to slip over each other. So when you are going to apply the force, these force is going to change the position of the metal atoms in the structure. So these metal atoms, which are arranged in the form of layers, so when pressure will be applied, they are going to slide over one another, and they can be converted into sheets, which is called as malleability, or they can be drawn into wires, which is called as ductility. So the question, when they are asking you why metals are malleable and ductile, so what you are going to write, you can write it: the metal atoms are arranged in the form of the layers. So when the pressure is applied, the layers slide over one another, and so that they can be converted into sheets and drawn into wires. So that's why they are malleable and ductile. So if you give the reference, of course, we can just give a reference from the structure, that in structure, the metal atoms are arranged in the form of layers. So this is these are the questions which we can answer from this explanation. So I'm going to wrap up everything now. In today's lecture, we discussed the 3 physical properties of the metals. The first property we discussed was metals are having high melting and the boiling point. And we also discussed the reasoning why metals have high melting and the boiling point. In the second question, we discussed how the strength of the metallic bond differs in the different metals or the metallic structures. We saw how we can draw these metallic structures like sodium structure, magnesium and aluminium structure. Then we discussed why metals are good conductor of heat and electricity. We also discussed the reasoning from the structure and from the bonding, then what can we write the proper explanation according to the marking scheme, that if they're asking you the question that why metals are good conductor of heat and electricity, explain it in terms of its structure and bonding, then how you can explain and write. So then the last question we discussed was the metals are malleable and ductile. What is the meaning of malleability? Malleability means to be drawn into sheets, and ductility means to be drawn into wires. So why the metals can be beaten into sheets or hammered into sheets? They can also use the word hammered or beaten. Somewhere in your reference books you will find the word beaten or hammered or converted into sheets. So that is malleability. That property is actually malleability. When the metal structures can be converted into sheets, that is malleability. And when the structure of the metals can be drawn into wires, that is ductility. So we also discussed that why metals are malleable and ductile. From its structure, we gave the reference and we given the explanation. So this was our lecture for today. Now I'm going to go back.